The production of chocolate is a multifaceted process involving numerous chemical reactions. The key stages where these crucial reactions occur to develop the proper chocolate flavor include the fermentation, drying, and roasting of cocoa beans, as well as the grinding and mixing of chocolate ingredients. During fermentation, essential precursors for subsequent chemical reactions are formed. Roasting is particularly critical due to the Maillard reaction, which produces aromatic compounds. In this article, we will explore the significant chemical reactions involving proteins, carbohydrates, lipids, and polyphenols. Additionally, we will discuss other components that may naturally occur or form during the production process, such as methylxanthines, aldehydes, esters, ketones, pyrazines, acids, and alcohols. Chocolate is a product widely consumed across generations and is rich in fats, proteins, carbohydrates, polyphenols, and other bioactive compounds. Cocoa beans are the primary raw material for chocolate production. The process involves several steps: fermenting, drying, roasting, grinding the cocoa beans, mixing all ingredients, cocoa mass, sugar, cocoa butter, emulsifiers, flavorings, and milk components if needed, conching and tempering. The key chemical reactions occur during the fermentation, drying, and roasting of cocoa beans, and in the production of chocolate mass. These reactions are crucial for developing the desired flavor and aroma. Cocoa bean fermentation is a process where yeast and bacterial growth occurs within the pulp at cocoa plantations. This stage is critical for creating essential precursors necessary for subsequent chemical reactions during chocolate manufacturing. Fermentation comprises 3 stages. First stage, dominated by anaerobic yeast, lasting for 24 to 36 hours with low oxygen and pH levels. During this phase, the yeast converts sugars into alcohol and carbon dioxide. Second stage, dominated by lactic acid bacteria, which become active between 48 to 96 hours. These bacteria convert sugars into lactic acid, lowering the pH further and contributing to the flavor development. Third stage, dominated by acetic acid bacteria as aeration increases. In this stage, an exothermic reaction occurs, converting alcohol into acetic acid, raising the temperature to 50 degrees or higher. This heat helps kill the seed embryo, stopping germination and aiding in flavor development. These fermentation stages are crucial for creating the complex flavor precursors necessary for developing the proper chocolate aroma. Drying of cocoa beans. After fermentation, the drying of cocoa beans is carried out to reduce moisture content and complete the oxidation processes initiated during fermentation. Once dried, cocoa beans have a moisture content of 6 to 8%. Low moisture levels are essential to prevent mold growth and stabilize the beans for transportation and storage. The drying process can be done naturally in the sun or using mechanical dryers. Proper drying ensures that the beans do not develop off flavors and retain their quality during storage. Roasting of cocoa beans. Roasting is a pivotal stage in chocolate manufacturing and is typically the first step at the factory. This high-temperature process is essential for the Maillard reaction, which develops the characteristic aroma and flavor of chocolate. Roasting also reduces undesirable components, decontaminates the cocoa beans, and facilitates the removal of the bean shells. During roasting, complex chemical reactions occur, transforming the flavor precursors formed during fermentation into the rich flavors associated with chocolate. The duration and temperature of roasting can be adjusted to achieve different flavor profiles, with lighter roasts preserving more of the bean's original flavors and darker roasts producing more intense and robust flavors. Grinding and mixing. Grinding and mixing all chocolate ingredients are critical to achieving the proper particle size and smooth texture. The main ingredients used in chocolate production are cocoa liquor, obtained by grinding cocoa beans, cocoa butter, obtained by pressing cocoa liquor, sugar, and milk, in the case of milk chocolate. The grinding process reduces the particle size of the ingredients to about 20 microns, ensuring a smooth and creamy texture. Proper mixing ensures that all ingredients are evenly distributed, which is crucial for flavor consistency and texture. Conching is a mixing and heating process that further refines the texture and flavor of the chocolate. During conching, chocolate is continuously mixed and aerated, which helps evaporate volatile acids, achieve the proper viscosity, remove excess moisture, and develop the desired color. This process can last from a few hours to several days, depending on the desired quality of the chocolate. Conching improves the smoothness and mellowness of chocolate, reducing any gritty texture and enhancing the overall mouthfeel. Tempering is the final critical step before molding chocolate into bars or other shapes. This process involves heating and cooling the chocolate to specific temperatures to form stable cocoa butter crystals. Proper tempering ensures that the chocolate has a smooth, glossy finish and snaps cleanly when broken. It also ensures that the chocolate does not develop a white, powdery appearance known as bloom, which occurs when cocoa butter crystals separate from the cocoa solids. Molding and packaging. Once tempered, the chocolate is ready to be molded into bars, bonbons, or other shapes. The tempered chocolate is poured into molds and cooled to solidify. A final inspection ensures there are no air bubbles and the chocolate is intact. The chocolate is then wrapped in foil or paper to maintain freshness and protect it from external elements. Despite their small appearance, chocolate bars generate significant revenue annually, requiring a substantial amount of packaging materials for wrapping. These processes must be carefully controlled due to the impact of chemical reactions and their products on the flavor and aroma of chocolate. The main flavor compounds in chocolate are polyphenols, present in raw cocoa beans and undergoing various transformations during production, and pyrazines formed during production, followed by aldehydes, ketones, and esters. Some reaction mechanisms during cocoa bean and chocolate processing have been discovered and identified. However, as new analytical techniques emerge, new compounds are being identified, e.g., saloinositol, 1-kestose, and 6-kestose cocoa acids. Their relevance in reactions during cocoa bean and chocolate processing and their impact on overall chocolate characteristics, flavor, aroma, color, remain to be revealed. Furthermore, as analytical tools become more sensitive in detecting and quantifying identified compounds, new knowledge in this field is anticipated. This knowledge will not only contribute to science, but also benefit cocoa bean and chocolate manufacturers who can select varieties and processes to increase desirable compound content and reduce less desirable ones, as well as optimize the ratios of different compounds crucial for overall quality. The production of chocolate involves a series of complex and meticulously controlled processes, each contributing to the development of the distinctive flavors and textures we associate with high-quality chocolate. Understanding these processes and the chemical reactions involved not only enhances our appreciation of chocolate, but also drives innovation and improvements in chocolate manufacturing. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.